let's continue for this chapter 3 of the tutorial. In the part 3, we have used part 1 to let's back to here. Part 1, we understand the object called the sphere, and we are familiar with the resizing. Part 2, we discussed just now about the 3 types of this balloon, the transaction, combining the object through union, difference, and intersection. Now, this part 3, we will use the skill we just learned for this combining and also the different the shape or the object shape to customize or update our car model. So you can see the primary change on the wheel now is not like our the sphere or resize the sphere, but we make that is more like a wheel. But you can imagine this looks like something, and we removed from a certain area. So let's do this exercise together. So let's back to here. Before we go to here, you can see our repository. I have updated the structure. If you go to this repository is on this OpenSCAD under my GitHub account. Under the tutorial, now I put this every chapter into the separate subfolder. So if you click that, you will find a snapshot of every model. If some model is interesting to export to STL, you can also get this from the GitHub, which you can review that before you try to utilize this model for your practice. So this video will continue on the chapter 3. So first, in the left, let's save on a new model. So let's back to GitHub, OpenSCAD tutorial. So let's see, this is the part 3, first one. We did this wheel with spherical sphere size. So that is our first model. So let's do this before we go to the view. So let's see. First, let's have this face angle and the face number. So that is 1. That is 2. So let's just keep those. And first, we have this wheel radius, make our perimeter. So that is 10. So once we have that, let's have this R equal to this one. So now we should have a base shape first in our this the dimensions x, y, z. And what we want to do is we need to do the difference. So difference means we will need to remove something. So how much we this radius we want to decrease is we gave our another the perimeter. So side spheres radius equal to, this can be a very big thing. So let's see. So we do this sphere as well. So we should have 2 another, because one is on this y, positive y minus negative y. So then we should have these 2 to do that. So let's see, it's big, so 50. and we need to let's make that transparent first. So now you know is our original the wheel the sphere is in the middle. So let's do the translate. Translate that to somewhere. So the x on the x axle is no move, but they want to move on the y, and then the z is 0 as well. So that is our syntax. But how much on the y is we don't know yet. But let's give this the rule first. So we need to do something like this. Then what's y is we move this. Then we want to the after the difference. It should have this thick. So this thick we gave our third. The parameter is half. We call this half thickness. So we want to see thickness is 4. Then this 4 means is we need to move. First is the sphere is in the middle. We need to move this to their radius. And after that is 1 is should move to more than half of this half. Then second is the less than, so also minus thing. So one is this direction, another is this direction. So that the reason is we should have this side. Spheres radius. So that is the first one, and then this should be added this half thickness divided by 2. So let's see. So that has some half thickness. Let's see what's the arrow. Syntax arrow in file line 10. So sphere R. So if we have that is let's see also sphere. So translate sphere. Oh, so didn't have close this one. So let's see. 1, 2 plus thickness. Spheres radius plus this divided by 2, and then this is spheres radius. Translate. Oh yeah, this is the second translate. So it's here. So you can see here using this minus means we translate to the another the y angle, y direction. So now it should be okay. It's also not good. So here let's make R sphere R equal to side spheres radius. Oh yeah, so again, sorry, I have didn't have that. So now you can see it's a 2 big sphere having this our original sphere in the middle. So what we want is we need this 2 sphere, big sphere as the knife. Now is we are adding. We have enough the perimeter. Then we need this as the base and minus this 2. So that's the difference we'll do for us. So we have this, and we can do this, and let's do this cap. So you can imagine is that will be left. This one. So you can see it's not directly like our the face, but it's from the sphere, because our sphere is very big. So under here is not it's quite flat, but it's not flat actually. So that is the thing is we are putting here. So that's the first one. Now we have a base of this new wheel. So let's make a save and moving on. And what we want to do is now we should have 4 holes here. How you can imagine is we do this. Actually, we can do this by the cylinder. So you can imagine is we should have our cylinder from the middle. Then is we move them to the 4 direction. So that is another the divide or the difference. So let's save that to the second one. So wheel with a sphere slice is the first one. Fill with these and holes. So let me save that. Another part. It's the second model. Sides and holes. The hole is let's make our cylinder. First is just our the cylinder. Cylinder. So you can see cylinder. You need our H is the height. First radius, top radius, or the bottom radius and top radius. So you need to define these 3 this perimeter. But since we want just our perfect cylinder, so R1 is equal to R2. So we can consider those. Then we need more perimeter. So first is our cylinder radius. Radius means this radius for this hole. So because we will do the difference that. So we put this 2 and the cylinder height. We put this that height. How long is of this height? The cylinder is we just want this. They don't have the hole should be cross this shape. So just the 2 doubles length of this wheels, or you can make that longer for safe as well. So let's put that 2 for is 2 for wheel radius. So now you can define new variables based on the existing variable, and then we can use the this cylinder. You can see is H equal to cylinder height, and R equal to cylinder radius. So let's see. So what this looks like. So you can see is by default the cylinder is coming from this Z, the axles. But that's for first find. So because it's not coming from the bottom, the reason is cylinder is not a sphere. It's starting from the this 0, the surface. So we need to have this center equal true. Then remember, look like here. So let's see. So now this cylinder is actually coming. So just for you to have some better view. So now you can see this is the cylinder's view. As I said, is 2 is just almost exact the length. So let's put that into 3. Then you can have a better view. So this cylinder is like our stick to cross this this shape. So that's perfect. And if you use the difference, is actually make this hole. But wait a minute, because we don't want this direction. We want this direction on the Y axle. So that's why we need to rotate. without rotates on the Z, the directions. So let's make our rotate. How to rotate is X. Rotate means they need to from the Z come to Y. So from Z to Y means they rotate based on the X. No matter is positive or negative, that is on the X is 90 degrees. So whenever you make this transformation, consider from the real this the space view. So I see, let's put this tab. So I hope it's that coming to here. If I want to show you the actual things, you can see it's like this. Perfect. Now what this program show you is we just need to duplicate 4 times of this, then move this from the middle to top, bottom, left, right. So that's no any difficulty. So that is the cylinder 1. Cylinder 1 is we will translate to upper. So how much? Is just to the middle of this radius. So the first one is we go to the Z. So means 0, 0, and then the wheel radius divided by 2. Don't forget about close the brace, and then make this tab. Then let's see. Translate. Okay, so we should starting from this. So now you see you have this upper, and then we will copy this 2, 3, 4. So you can see you can always reuse as much as possible of your code. So first is then, second is go to the below of this. Let's look at. So second hole. And the third one is not from here, is go to the X direction. So that means it's first is X, then 0, 0. And the minus 0, 0. So that should be like this. So we have this one. So if you don't have this percentage, you will get the perfect result, like this sample. So that is, you can see now you have our more the nice shape. So that shape is looks not from the beginning, is but we can build such kind of shape is from the very basic sphere cylinder. It's nothing more complicated. But now you can make our more realistic real wheel. So that is our second part, and the third part is let's try to use this wheel in our car. So first is let's create our new file. So let me save that on this one. So car with wheel with spherical size and holes. So let's see car with. So now these are our third model. So first is remember we need this the sphere to replace our original sphere. So we should build this one. So this as our sub program. So but before we have using those the sub program, the concept, let's just try to repeat this. So we need for this portion. So first, let's copy this to be used. So something is we can use is this wheel radius is okay. The side, hub, cylinder, and the cylinder radial height. So those are the parameters is based on to make our those wheel. But we also need to have some the cars. So let's just rebuild our car. So we have the base height. Remember is that is 10, and the top height. Yeah, I just redraw this, rewrite that, let you know is how easy for us to rebuild our model. And the track is the axle, so it's 35, and the wheel width we don't have that, and we have the radius, so wheel width. Is 10, and the body roll, that's nothing. Wheels turn is nothing for now, but you can turn your wheel first. And all these parts are of the wheel with the spherical sides and the hole. So we need to repeat this 4 times to build our the car. So first is let's make this our body first. So this is our body. So let's copy that to our program. So it's like this. So what we will get is so side with a sphere, base height, center base height, arrow, so 47. So 47. This one. Oh, so I think it's I forgot to copy this closing, the parentheses. Yeah. So now you can see, so we have our car body back, and also we need this our car's the axle. So let's copy this back. So these 2 parts are no difference. So that is our car. So now what we will do is we need to use this the new wheel 4 times, and every time is we will make them the rotate 0. You can see the rotate is 0 because we already put that into the correct direction. So all this can be reused, and what we need to do is just this translate. Translate is using the track, this parameter, and then is in the X we will use 20 because we have our these axles on the 20. So here. So that is the thing. It's quite easy. So translate 20, and track is on the Y. So you will see is we have a positive Y, negative Y. So we're starting from the X is this 20, and the negative is this way. So we should draw this one. So let's use the minus, track divided by 2, and then the C is 0. And then we put, we don't need this rotate. So we just have the this difference and put them into the inside. So let's just have a look. Perfect. So we have the first wheel. And then what we need to do is just try to copy 1, 2, 3. So we have now 4 the wheel. All the wheel now is on this same the direction, same location. So that is the first one. So for, and then we remember we can put this into the minus and this into the positive, this to the minus positive. So I think is we have 4 wheels on our car. So that is the thing. So because now you can see if I when I move on my cursor, is getting very slow because we have putting the surface the smooth. So if you try to render that, you will get also slow. So I don't do this rendering, but after all, now you get this exact same model like the tutorial. So you can see is when you build something, starting from build the basic, then use that repeatable, and then you can make that reuse into the different location and the position, try to transform them, and you can just extend your imagination on this luxury model. So those are the end of this tutorial chapter 3. So when we back here is next chapter, we will starting to use and define the module, because now you can imagine is how easily you can make your the program is large, but this program actually is repeated too many times, especially this those difference are exact same. So how we can save some lines of our coding will be similar like other program languages. Let's starting to understand the modules, the usage from chapter 4. Thank you for watching. Have a nice day. See you later.